Today we're going to use a test that's very useful for understanding the distribution of two populations and whether they're the same. And it's called the Kolmogorov-Smirnov test. Bit of a mouthful, so we'll try and just call it the KS test throughout. So let's consider an example. If we've got two groups of things, populations, in this case we've got males and females, and we've got the heights of males and females. We could look at plotting the average height of males and the average height of females and seeing if they're different. But another interesting thing to do is ask whether the distribution of heights is the same for the two groups. So here we have some data and we can see that there are differences. We could plot that distribution in a histogram chart. And that'd look a little bit like this. You'll see that in the orange we've got the female distribution of heights. The distribution is to the left, if you like. There are some short people and no very tall women. And in the blue we can see the distribution of males, and we can see that in fact there's more tall people and very few short ones. So just by eyeballing that we can say, yep, there looks like there's a difference. But if we want to attach a statistical significance to that difference in populations, we use the KS test. So that's what we're going to run through today, and I'm going to try and make it easy for you to follow how to actually do this test. So we start with opening up SPSS. All the Trobe University computers, as far as I'm aware, the teaching computers have SPSS on them. And here we are, we scroll down and we find the program. It's called IBM SPSS Statistics. We want to open the program, which is what we're doing here. I'll get rid of this PowerPoint, hopefully. Slowly opening up for us. Here we go, great. And what we want to do is get rid of this stuff. So I would typically either just cancel this, or you can go up to the top left hand side and you can click on new data set. And given we're starting a new data set, why don't we do that? Double click it, and what we end up with is the typical SPSS worksheet. Many of you have already used this before, I know. Down in the bottom left hand corner are two views: the data view, which we've currently got the worksheet open for, there's no data, and what's called the variable view. So let's click on variable view because that's where we want to start. To do the KS test, we only have two columns, or two things that we need to define. The first column is going to be our groups, and so in this case we've got males and females. So why don't we call the first group, the column here, sex. And we're going to compare two things here. So we type in the name of the group, and once we click off that, it will populate some things. It says numeric, the width and the decimals. You don't need to change any of this. But the thing that you do need to change here is the thing called values. So click on that, and this is going to define our groups. So I'm going to make it really simple for us today. We're going to have two groups, 1 and 2. So value 1, we can give a label to. Let's call that male. And we add. And what that's done, it's created a grouping variable number 1, which are all the males in our data set. So it's pretty obvious that value number 2 is going to be labeled female. We add that, and now we have two groups ready for getting some data in. So we'll just say OK. What we then need to do is we need to look at this thing over here called measure, and we need to change that. Initially it had scale, I think. What we need to do though is to change this to what's called nominal. Nominal just means the data has been recognized as a grouping variable. So click on nominal, that will recognize groups 1 and 2 as male and female. That's all we have to do. Okay, now for the data, this is going to be the distribution of heights of males and females. We had 11 males and 9 females. So I'm just going to call this data. You can call it whatever you like. It could be heights. In fact, why don't we call them heights? Again, click off that and it will populate some stuff. And we go back to this thing called values again, and we need to change it. It says none at the moment. So if we click on that, it gives us this labeling system again. Now what we're not going to do, and what's really important in the KS test, is we don't put the raw data in, we're going to put the data into size classes. So we're going to identify how many females ultimately fell in a size class from A to B. So watch what I do here. We're going to keep it really simple. We're just going to call the size classes 1, 2, 3, 4, 5, and 6. So type in 1 for our first size class. The label here is to help us understand what that is. And I'm just going to type in 140 to 150. And what I'm saying here is category number 1, label number 1 relates to people who are in this size class, 140 to 150 centimetres. This will all become apparent when we put the data in. Let's add it. Category number 2, I'm going to call people who are in the 150 to 160 size class. We add. Category number 3 will be people in the 160 to 170 size class. We add. Category number 4 will be people who are in the 170 to 180 size class. People in category number 5 are going to be in the 180 to 190 size class. And category number 6, that's for very tall people who are in the 190 to 2 metre size class. Really important you have categories in the KS test, not the actual raw data. So we're done there. Now we just need to go over to this thing called measure again, the second last column, and where it currently says unknown, we change that to ordinal. And that's just saying it now knows that our data is categories 1, 2, 3, 4, 5, 6. It's not continuous data. So we've set up the data sheet, and now we can do some data entry and analysis. So we flick back down to the left-hand corner here and we click on data view. And so straight away what we have now are sex and heights as our 2 categories. They were the 2 things we just defined. We have 11 males in this data set and 9 females. So what I can do straight away is populate in the first category the sex of each individual in the study. So I'm just going to type 11 times 1. 1 equals male. And there we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And now I'm going to type the number 2, the females, 9 times. That's how many objects there are. So this column will be as long as the number of objects or observations you have made in the data. So if there are 50 objects, it'll go down to 50 in columns. So let's just type in 9 times females. 2, 2, 3, 4, 5, 6, 7, 8, 9. So it's an unequal data set, doesn't matter. Let's go back up to the top. And now we're going to enter data in the second column called heights. So we're not entering the raw data, we're entering the categories 1, 2, 3, 4, 5, 6 that each individual will fall under. So let's just show how that works and then we can go through it rather quickly. In the males, so sex, number 1 is a male. My very first individual was 155 centimetres tall. And we've identified a group, category number 2, for individuals between 150 and 160 centimetres in height. That's their size class. So we type 2 here and we go down. The next individual was 167 centimetres tall. So he falls into a category called 3, 160 to 170 centimetres. The next individual is 183 centimetres tall, so he falls into a category 5, between 180 and 190. So 5 goes in there. So what you can see is I'm putting in the categories, the size class for the data, not the original data, really critical step. So I'm just going to go through and now populate the data set based on all the individuals. So bear with me. What are we up to? 181, so that will be another 5. 190, so that'll be a 6. 160, so that'll be a 2. 173, 4. 173 is a 4. 181 will be a 5. 191 is a 6. And I'm up to the last one, thankfully. Good. 175 will go into the category 4. So I've now done all the males. I'm just going to now do the females. Same thing. 161 is a 3. 149 is a 1. 153 is a 2. 163 is a 3. 177 is a 4. So a bit more variability here at the moment. 168 is a 3. 171 is a 4. 159 is a 2. And our last individual, hopefully, yep, is 166 tall, so they fall into category 3, size class 3. So now we have our data ready to analyse. We've got a column of objects, males and females, 1 and 2, and we have a column of data by size class in 10 centimetre intervals. So to do the test, simple as analyse. We go down to non-parametric statistics or tests. So what we're doing here is we're comparing the distribution of these two groups of people, males and females. We're not assuming that they're normal data, that they have equal variance or anything like that. We want to know, are the two populations similar in their distribution of data or different? That's all we're asking here. Really good test. From there, we go down to what's called legacy dialogues. Don't know what that means. And we then go down to 2 independent samples. And you can see, hopefully on the image there, it's showing 2 distributions. And that's what we're interested in testing. Click that on. We then are faced with this kind of dialog box. So what we're interested in is the grouping variable. They're our groups, males and females. So we click that on down to there, and we have to define the groups. That's pretty easy because we've already called them just 1 and 2. It's easy to keep this simple, or best to keep this simple. Now we don't want to do a Mann-Whitney test. What we want to do is we want to click on the KS test, which gives us what's called a Z statistic. So we click that on, and we're ready to go. Oh no, we're not. We have to say what's our test variable, of course. Okay, we're interested in heights, the thing that we put into classes. Now we're ready to go. So what's going to happen? Push the button. It'll run some magic, and we'll get some outputs. So let's have a look at the outputs here. It tells us firstly the frequency, and this is good. We had 11 males in the sample, 9 females, total of 20. So I believe that I've put the data in correctly. That's terrific. And we go down to this point down here, and hopefully you can see the Z statistic 1.124. That's just like, that's the statistical test. It's telling us what we've found here. And this is the important point here. The two-tailed significance test comes out at 0.160. And that actually means that the two distributions are not significantly different from one another, probably because the sample sizes are quite small. So whilst they look different when we graph them by histograms, the KS test tells us that they're not statistically different. It's not less than 0.05. That's the critical threshold you're looking for. So that's how to do the KS test. I hope that you can follow that in your own examples where you need to use this test. You will find with bigger sample sizes that it's likely that populations will differ in their distributions because you have more data on which to base this test. Good luck and happy statistics hunting.